Elon Musk and NASA have unveiled a light-speed engine that is quicker than anything previously seen in the aerospace industry after years of testing. In their mutual desire to explore the depths of space, Musk and NASA have been working together for some time. They have taken a step toward realizing their dream by successfully testing this new engine. But what distinguishes this engine from others? Can it make it through the meteorite adventure and arrive safely? The potential of the new light-speed engine is a subject of disagreement in the scientific community, and I'll explain why. Welcome back to another exciting video from PrompTech. Today's video is about Elon Musk and NASA finally reveals new light-speed engine that defies physics. Before we start the video, please like, subscribe, and press the bell icon. The problem with space travel. By 2050, Elon Musk hopes to enable successful human travel to Mars. Elon has a reputation for producing results, so NASA collaborates with him to make that happen. However, the idea of space travel has been fraught with difficulties, mainly a trip to. The average distance between Mars, the fourth planet in our solar system, and the Earth is 140 million miles, and it would take a rocket traveling at 15,000 miles per hour for at least 7 months to reach there. Methane, as opposed to kerosene, is the primary fuel utilized by modern rockets. Furthermore, this fuel must be prepared and put into the rocket before liftoff for a successful flight. However, a missile that uses 11,000 pounds of energy every second day would need how much fuel, space, and fuel? The reply is a big one. This is taken into consideration while building a rocket to undertake such a hazardous voyage, as designing spacecraft necessitates striking a balance between the weight of the vessel and using fuel as sparingly as feasible. Imagine you are looking at the starship that is now on the Mars special mission. In that situation, only a tiny piece is set aside for the and most compartments that contribute to the craft's weight store fuel and supplies. The spaceship is 120 meters above the ground and has 33 Raptor engines, which can produce a thrust of 500,000 pounds. It will also be challenging to have enough gasoline for a trip to and from Mars, even though the engine is built to be fuel efficient. This explains why robotic missions using smaller rockets have been the only successful Mars missions. If they were to use braking to put the rocket into Mars orbit safely, it would require additional fuel added to an already large spacecraft and increased since there was no need for personnel extra fuel or supplies needed for the accrued trip. Even a space enthusiast like Elon Musk knows the path ahead will be demanding. As he mentioned, such a trek would be hazardous, uncomfortable, challenging, and laborious. The potential of the new engine. Chemical rockets often operate under the principles of Newton's third law of motion. It affirms that the action and response forces' size and direction are equal. Since they all use thrusters, the Falcon 9 space shuttle and the present Starship under construction also support this notion. Fuels like methane and oxygen must be combined for propulsion to occur. To speed up takeoff, hot exhaust from a combustion chamber often gashes steam and channels water via a nozzle. However, this light-speed engine has a different goal in mind. Explain the rules that have been established for agents. It won't require fuel to move. Space relativity states that objects gain mass as they get closer to light. The engine works by enclosing ions in a loop, accelerating them to modest speeds, and altering their velocities just enough to modify the mass of the ions. To generate the required thrust, the engine will cycle the ions back and forth in one direction. The ions trapped inside electric and magnetic fields will be the only moving portions of the helical-shaped machine, which will resemble a stretched-out string. This light-speed engine will use the electromagnetic gadget to generate thrust without fuel. A contentious propulsion mechanism. According to David Goodwin, any rocket can travel faster and farther into space than with any other propulsion system, if the vibration from electromagnetic waves or ions can be focused in one direction. It might develop a propulsion system that is efficient enough to reach speeds of less than 1% of the rate. However, the concept of producing propulsion without any fuel is familiar. Goodwin oversaw a NASA breakthrough propulsion physics project in 1990 with the aim of creating a propellant-free propulsion system. In reality, Roger Shur created the first instrument, demonstrating the concept of a reactionless drive in 2001. Why are scientists opposed to the new light-speed engine if it has such great promise and can help humanity realize its aim of exploring the upper heavens? The setbacks of the engine. Scientists from the US, the UK, and China have shown how electromagnetic propulsion would function since the initial demonstration in 2001. However, some argue that since the propulsion is unknown, there are better times to celebrate. Since the initial experiments were not conducted in a vacuum, its practical application has yet to be verified. According to some, producing energy in a quantum vacuum is impossible, since you cannot ionize particles there. Before the project even gets off the ground, measurement errors and uncertainty might result if these studies evaluating a minor effect of the gadget were deemed significant. We must think about how much it will cost to operate. It would be costly and time-consuming to use an M drive. It has already received $5 million from NASA, and it is unknown how much more will be required to improve it. Additionally, the law of conversion of momentum, which states that an object's rate remains constant in the absence of an external force, conflicts with Newton's third equation of motion when acceleration is achieved in rocketry without a catalyst, as this engine seeks to do. It is impossible that this new engine will surpass the limits of recognized physics that apply to all known forms of motion, because the idea of momentum conversion is well established in physics. Will a rocket be able to withstand the mediate adversity? A meteorite travels at 120,000 miles per second when it approaches the atmosphere of Earth. It burns ferociously as it travels through the atmosphere of the Earth before settling on the Earth. We now understand that a meteorite is a piece of cosmic rock strong enough to survive impact with Earth. Can a rocket powered by an EM drive withstand the same effect? It might burn upon return if it moves at the speed of light, which is a bad outcome. Additionally, rockets had to be fired toward the Earth to halt descent during past Mars landings. How will the new rocket successfully land if it doesn't intend to use thrusters? The spaceship needs to have the right propulsion system, since the atmosphere on Mars is dense enough to burn the rocket upon entry. Skeptics rejoiced when a Dresden University team led by Martin Tamar revealed a weakness in the new Lightspeed engine. The test showed that another electromagnetic interaction, rather than the EM drive, may be the source of the push. The study claimed to have found significant gaps in earlier research that suggested it could be hard to build a functional Lightspeed engine. Nonetheless, NASA has succeeded in disproving other researchers' skepticism. A team of scientists at EagleWorks Laboratory conducted a series of tests as part of a NASA-funded study that looked at an EM drive in conditions resembling those in deep space. These testing revealed a 1-to-thrust-to-power ratio. More than any calculation anticipated, the drive could function and open up new possibilities. In defending the EM drive when talking about space, Roger Sawyer claimed that the well-praised negative experiments were based on a defective design and could not be taken seriously. It is impossible to entirely rule out the drive as a feasible choice for space because of the conflicting assessments and testing that have been done on it. Thanks for watching the video. If you enjoyed it, please like, share, and subscribe to our channel for more exciting content.